Hello, everyone, and thank you for joining our webinar, Dremio and Microsoft Deliver a Full Stack Solution for Cloud Data Analytics. My name is Jeremiah, and I'm the Partner Solution Marketing Director for Dremio, and I'm delighted to be joined by James Baker, who is the Program Manager for Azure Storage at Microsoft. Before we get into the presentation, just want to go through a couple of quick housekeeping items. We have about a 40-minute presentation and a demonstration, followed by live Q&A. You don't have to wait until the end to ask your questions. Feel free to pop them right into the platform, and we'll get to them as we can. If we don't get to your questions, both of us have our contact information at the beginning of the session, so feel free to reach out. Now I want to go over a quick agenda for our time together. First, James is going to set the stage with Microsoft's vision for analytics in the cloud and how ADLS plays into that vision. Then I'll talk a little bit about what I'm calling the data-driven gap, and then go into the growth of data lakes and really how we got to the open data lakehouse architecture. Then I'll share how ADLS, Dremio, and Power BI come together in a customer story, and we'll close out with a demo of the three technologies together. So now I want to pass it over to James to kick it off with Microsoft and analytics in the cloud. Over to you, James.
Cool, thanks, Jeremiah, and hi, everyone. It's great to be here today. So look, even though, as Jeremiah explained, I'm here and I'm part of the Azure Data Lake Storage team, we've got to think about what Microsoft Azure does in terms of delivering a platform for analytics. The Data Lake Storage service is an integral part of that, and that's obviously a unifying abstraction layer underneath all of the analytics frameworks. But we've got to make sure that we're delivering an end-to-end platform that works for all of your analytics frameworks, whether it's your ingestion tools, your data processing tools, your data consumption tools. All of that has to live on the platform and all integrate in over the data lake storage layer. And so, when we deliver the data lake storage layer from a platform capability, not only are we delivering a storage service, we're delivering the sort of glue that glues the whole platform together. But at the end of the day, as I say, it's about building end-to-end data pipelines. And, we need to provide a comprehensive platform that's capable of doing that. So not just the storage layer, not just sort of really cool data processing engines like Dremio, but data integration tools, data governance tools, all of these tools, data consumption tools, all of these things are super critical if customers are going to succeed in building out an end-to-end data pipeline. And so this is very much the focus of what we're doing. But then drilling down specifically into Azure Data Lake Storage, as I say, it's the sort of ubiquitous glue that plumbs together the whole platform. And so, we do need to look at what the critical capabilities of the storage service are. The first thing is that it's based on our globally available, fully distributed, highly scalable Azure Blob Storage service, which is an object store. But what we do with ADLS is that we layer a file system over the top of that object store. It's not only that file systems give great performance around things like directory manipulations and so on like that, but also all of these analytics frameworks are designed assuming that there's a file system that's underpinning them. And that's what Azure Data Lake Storage does. But on top of that, we deliver it globally available, so it takes advantage of Azure's global distribution footprint, and that's critical in terms of making sure that the platform's available where you are as the customer. We don't create silos. We don't create sort of purpose-built solutions where you've got to move data from one purpose-built solution during one phase to another purpose-built solution during another phase of the data pipeline. We make sure that Azure Data Lake Storage is delivering best capability across the full breadth of that pipeline. Cost effectiveness is super critical. At the time where we're dealing with these sort of huge volumes of data, You've got to get cost efficiencies out of those things. And so the first step is doing that on top of the cheapest storage solution today, which is object storage. And then by layering capabilities up on top of that object storage, we're still able to stay very close to that cost-effective layer that is super critical for these things. The scalability also is, again, critical. We're not talking about, a few megabytes or a few gigabytes of data. We're talking about multi-petabyte installations, and these have to scale and scale linearly. And that's, again, what we sort of stay focused on in terms of not only Azure Data Lake Storage, but the entire platform. Security super critical. If data is genuinely the new oil for all of these enterprises, then we've got to make sure we can secure it. And so having rigorous and yet flexible security mechanisms that allow auditability and flexible capabilities is, again, super critical, and we've got great solutions for that. And then the resilience. You want it to be there and available, and you want to be able to recover from things like disaster recoveries or availability outages. And so we've got mechanisms where we have failover schemes, we have highly available schemes, and that's all super critical, again, to what the capability of ADLS brings. So that's the brief perspective from Microsoft. So Jeremiah, I'll throw back to you to talk more about how Dremio plugs into that platform.
Sure. Thanks, James. So I want to talk about the evolution of data architectures, and I want to level set with this idea of the data-driven gap. So these are some responses to an IDC survey, data culture survey from 2021. And it found that executives overwhelmingly want their organizations to be more data-driven, and CXOs really care about becoming an intelligent enterprise. But there's a massive gap between what executives want and the reality on the ground within their organizations. So while 83% of CEOs want to be more data-driven and 87% of CXOs want to be an intelligent enterprise, only 30% of respondents to this survey said their actions were driven by data, and only 27% say they communicate regularly using data. The reality is there's far more data coming into our organizations than ever before. Another IDC report estimated that by 2025, there's going to be 175 zettabytes of data worldwide. And importantly for our conversation here and for ADLS, as much of that data will reside in the cloud as on premises by 2025. And we're dealing with more data access requests from both technical and non-technical data consumers who need fast and easy access to insights from data to do their jobs. That includes data scientists, business analysts, executive dashboards. All of these require data. And all of this means there's far more complexity in our environments. There's new data sources, shifting storage paradigms and data architectures, more people who need data. All of that means that we need to dramatically rethink the way that we work with data. So I'm going to get to the open data lakehouse, but I really want to go back in time first and start really from the beginning. Decades ago, businesses made heavy investments into the enterprise data warehouse, and it was really great at what it was initially designed to do. So it could store and analyze primarily structured data from business systems housed alongside it in the data center, and it can make that data available for business intelligence and reporting tools in a reasonable amount of time. These systems were often proprietary and appliance-based, so they struggled to scale. So we added, over time, the volume, variety, velocity of data changed. All of a sudden, we were collecting semi-structured and unstructured data, primarily from systems outside of the data center, and the EDW struggled to meet the demand. So a lot of companies invested in the data lake. And the data lake was also really good at what it was designed to do. It worked great as a cheap repository for a lot of different data types. It was really good for small scale exploratory data science projects with small teams of data scientists. but it really struggled to fully replace the legacy enterprise data warehouse, especially with Hadoop on premises, which struggled to meet the concurrency requirements of enterprise-grade BI and reporting. And so what you get in most organizations today, I would say almost 100% of organizations today have some sort of combination of data lakes and data warehouses sitting side by side, generally doing exactly what they were always designed to do. Data science is still done in the data lake, and BI and reporting is still done in the data warehouse. And then if you have an important source of data in the data lake, the data team would build an ETL pipeline and move that data into the warehouse in the proprietary format that it needs to be in for analysis. This works great. The challenge as we are coming into the next sort of era of data analytics is that the newest and fastest growing sources of customer and operational data in the data lake are going to, or are semi-structured, unstructured data that's going to land in the data lake. And more people are going to require access to that data for BI and reporting workloads. So ultimately that requires more ETL pipelines, which are often manual and ad hoc, and that moves data into the data warehouse. On the other side of the equation, data consumers often require custom data copies in the form of BI cubes and extracts in order to meet performance requirements and SLAs for dashboards. So this creates a web of complexity that can often lead to a backlog of data access requests and ultimately reduced data scope and flexibility up the stack towards the data consumer, where most data consumers today actually need and want more flexibility and access to all of their data. So that's where the data lakehouse comes in. So Dremio is an open data lakehouse. It provides customers with direct access to data in the data lake. The lakehouse essentially brings data management, data governance, and data analytics capabilities that you would typically find in a data warehouse directly to ADLS. Dremio gives customers a lightning-fast SQL query engine that can query data in ADLS and in other repositories, including your relational and NoSQL databases, on-premises sources like your legacy EDW or Hadoop, and cloud and object storage vendors on premises. It features query acceleration in the form of reflections, which are optimized views that accelerate complex queries. And finally, it provides a built-in semantic layer that centralizes data management and data governance for data teams, but still provides broad access to data for data consumers of all skill levels so they can join and query data across the organization. Dremio is a no-copy architecture. So you analyze data in place wherever it resides. You don't have to build ETL pipelines or create data copies. The semantic layer bridges the gap between legacy and modern data environments, as we'll see in our customer example in just a couple minutes. And finally, Dremio connects to a number of popular BI and visualization tools, including Power BI, so more people, especially non-technical data consumers, can access and explore data and share insights across the organization with other data consumers and stakeholders. So we call Dremio easy and open. It's easy because it takes just a few minutes to get started. It's based on SQL, so virtually any data team and any data consumer can pick it up and use it without a ton of upskilling or hiring new talent or skills. And it's also easy because it dramatically simplifies access to data in ADLS. It's open because it's built on open source technologies and processes. Dremio's query engine is based on Apache Arrow, which is one of the most popular open source engines and is capable of querying data in a wide range of data stores. With Dremio, data can remain in ADLS in open formats. Open formats for data reduce the risk of lock-in, where it's difficult to get data out, and lock-out, where data is only available to certain tools. Open is really critical for data where we've seen really massive shifts in technology and data architectures in a relatively short amount of time. So the Dremio Open Data Lakehouse with ADLS is really a win-win for data teams and data consumers. Data consumers achieve faster time to insight, both because they have faster access to data in ADLS and because of query acceleration. Many of our customers typically report anywhere from a 4 to 100 times better query performance with Dremio relative to other tools. Data engineers are more productive. They don't have to spend all of their time responding to data access requests and managing and maintaining that complex web of ETL pipelines and data copies. They can work on the projects that are really going to move the business forward from a data perspective. Data consumers are much more self-efficient. Even non-technical data consumers can join and query data and do simple transformations on virtual data sets where normally they would require a data team to accomplish those tasks. And finally, many customers experience reduced costs associated with the simplified architecture, as well as not having to move data around or maintain multiple data copies in their architecture. Before we show you ADLS and Dremio and PowerBI in action, I want to put what we've talked so far about into context with a customer story. So this customer is NCR. They are a large software company, and they got their start back in the 1800s as the manufacturer of the first mechanical cash register. Today, they are a hardware and software vendor. They provide POS and other software and technology solutions for a number of industries, including banking, restaurants, grocery stores, and more. So as with any enterprise, NCR was dealing with a massive influx of data and a legacy on-premises data architecture that really wasn't designed to manage that data growth. They were spending a lot of money on data warehousing and also on external data consultants that they needed to sort of make sense of everything and get to the insights. And they struggled from a business level on what they call revenue leakage. So with the lack of data and insights into their customers and the customer journey, they were missing opportunities for cross-selling, upselling, and also customer service opportunities. So they needed a modern data architecture, and they chose Azure on ADL and ADLS. They chose Dremio for a few reasons. First, they wanted self-service analytics and found Dremio's semantic layer could empower more of their data consumers to get access to insights from their data. Second, they saw the value of ADLS as a highly scalable and flexible storage solution. So they wanted high-performance analytic capabilities directly on cloud object storage. And finally, they wanted to move away from their on-premises EDW towards the cloud for what they saw as potential cost savings. Here's a look at what they built, the high-level architecture. Essentially, they had two environments. They had their legacy on-premises data warehouse and data lake, and then they also had a modern cloud architecture with Synapse serverless exporting data into ADLS in the cloud. Dremio acted as a semantic layer between the two. So that joined their legacy environment with their modern environment. The key capability here was Dremio's ability to enable business users to join and query data in their on-prem and cloud data stores as if it was all one environment. And that would allow them to build dashboards and visualizations based on all of their data in Power BI. As they modernized. I also want to make it very clear they are migrating more and more to the cloud. This was a way for them to modernize and also get the insights as they migrated. As a result of this architecture, NCR was able to accelerate their migration to the cloud. They were able to recreate data pipelines in just days instead of weeks with Dremio. And with Dremio as the bridge between environments, that gave their teams, and especially their executives who were a little cloud hesitant, the confidence to move to more cloud solutions and migrate faster. They reduced their time to data, both by shortening the development time of data pipelines and also by reducing development costs. They also saw improved performance. Dremio accelerated their queries by 10 to 30 times. and complex queries typically took less than 30 seconds to return results. Most importantly for NCR, they were able to really understand the entire customer journey, and they reduced revenue leakage by having a better understanding of where there were opportunities for cross-sell, upsell, and more service engagements to retain and also grow their customers. So that's it for our portion of this presentation. I would like to let you see all of this work together in action. So I'm going to turn it over to Brett Roberts, who is our principal partner solution architect. And he's going to show you how ADLS, Dremio, and Power BI work together to create some pretty cool dashboards. Over to you, Brett.
Well, thanks, Jeremiah and James. Good day, everyone. My name is Brett Roberts, and I am going to show you how Dremio can connect to your Azure Data Lake Storage and how you can use Dremio to query data on Azure and then visualize that and run analytics on Power BI. So first, we're going to log into the Dremio user interface here using my email. And what you see here is the Dremio home screen. And I'm going to quickly orient you to a couple different areas within this home screen. On the bottom left here, you see sources. These are all the different data lakes and external data sources that you can connect to with Dremio. And it's very easy to add a source like a Azure Data Lake Storage by clicking on Azure Storage and adding and naming the connection, adding your account name, and then authenticating. And it's that easy to create a connection. And you can see here we have an example of just that, where we are connected to a Azure Data Lake Storage account. You can also connect to external sources like Microsoft SQL Server and even Microsoft Azure Synapse. Up here on the top left is what we call spaces. And spaces is one of those building blocks of the semantic layer that Jeremiah talked about. And with spaces, you create a series or a number of different directories for users to save views of the data. Remember, Dremio doesn't copy or store data, but we do create views or virtual data sets, which is really just a SQL syntax or SQL statement on top of that physical data that's sitting in Azure. So these views are different, or these spaces are different directories, like business, for example, where you can store virtual data sets for teams to access. And organizations do this a number of different ways. You can create spaces based on team, role, location. It really just is a directory for you to store and collaborate across organizations. And then in the middle here, you have your home spaces, which is really set for you, the user, to work on data, upload Excel spreadsheets, create views that are maybe not ready to share with your organization or your team yet, but you have this space here it's kind of like a workspace. So now that we've oriented to the Dremio home screen, we're really going to show how users can use Dremio to interact with the data directly on their Azure Data Lake Storage and then connect that to Power BI. So I'm going to put on my data consumer hat for a second, and I'm going to access Dremio, and I'm going to search for a data set that I need to run to create some dashboards within Power BI. So I'm going to go into our Dremio search bar, which searches the spaces and all the different data sets. And for this example, I'm going to search for NYC taxi data. So I'm going to type in NYC and taxi, and Dremio returns all of the physical data sets, which are just tabular views of the data in the lake, and all the virtual data sets, which are these green tables that we talked about earlier. And you can see that Dremio has returned all the different data sets that have NYC or taxi in the title or in one of the fields in the data set. And there's a couple here. But you can see this one here, NYC trips, also has these tags here: gold, cab, taxi, NYC. Tags are another fundamental building block of the semantic layer that helps data consumers like myself easily understand what the data set is, and helps me identify what I'm looking for a lot quicker. I might not know exactly where all the data is, or I might not know what data sets are out there. The tags help me quickly identify something that might be relevant to my search criteria. So let's click on this data set here, and you can see that Dremio brings up a preview of the table, and you can see all the different fields here. As you scroll, we have pickup dates, drop-off dates and times, passenger counts, trip distance in miles, which is interesting. We have some geographical data in longitude, latitude, and so on. If we look at the top here, we have a couple of different tabs that we can toggle against, and let's look at catalog. Catalog is another semantic layer building block which allows organizations to provide a wiki-like experience to each data set. And you can see here that the data owner created this wiki to show all the different dimensions and measures, so all the different fields in the data set, the volume of this data set, so I see here this is 1 billion records, so a very robust and large data set, and then data quality and description of the data set as well. So as a data user, this is extremely helpful for me because I can very easily either validate that this is the right data set that I want to use, or I can validate that this isn't the right data set and move on to search for another one. But this looks like a very robust data set that has all of the right fields for what I want to do and the analytics that I want to build in Power BI. The third tab here is a graph, and this shows a lineage of the data set. So you can see here that this data originated in the Azure Data Lake Storage. There was a parent data set, and then this one here is the child data set with a ton of children data sets that were derived from this as well. So it's been used by a lot of people in my organization, but I can see where this data set came from. And then the last tab is reflections. And reflections is one of the acceleration technologies that are built into Dremio to help organizations really get that scalable, fast BI that the enterprise needs, right? When we think about 1 billion records, which is in this data set, traditional query engines might take a while to query that. But reflections is one of those acceleration technologies that Dremio has to help speed up that query, as you'll see in Power BI. And really what a reflection is, it's just think of it as a materialized view of the data. And there's a couple of different ways that you can apply that. You can apply that at the row level using a raw reflection, or in this case, an aggregate, which is really doing pre-calculations or indexing these dimensions and these measures, and then writing that as a Parquet file back on your Azure Data Lake. So now that we've validated that this is the right data set that we want to use, this is something that is of interest to us, let's go ahead and connect this to our Power BI instance. And we're going to do that by clicking this Power BI button here. That creates a PBIDS file, and we're going to click on that, and that's going to automatically load our Power BI desktop instance. And it's going to create a connection to Power BI and to Dremio, and we're going to load the data. This is going to be a live query. And you can see here that just by clicking that PBIDS button, we automatically not just create the connection to Power BI, but we create the connection to the table that we were looking at in Dremio. So we didn't have to go through the schema, we didn't have to go find the table, we didn't have to load anything. The data is still sitting in Azure today. Dremio is providing a live query back to Azure when Power BI sets a SQL statement back to Dremio. So you can see here we have all the same fields that we saw in Dremio. Okay, so now that we're in Power BI and we're connected to our Dremio data set, we can start to build our dashboards and our visualizations. And we're just going to do a very quick one real quick to show how this works. And we'll do this by selecting a chart. We'll do pickup date by the count of records. And you can see here that we are looking at the count of records by pickup date for the duration of this data set, which again, if we remember going back to the catalog in Dremio, was 1 billion records. And you can see here that you have a ton of results, but Dremio returned those results in near real time. So if we go back to Dremio, and we go to the Jobs tab here, you can see that this was the job that we just ran. You can see count and pickup date by pickup date, and we saw a duration of sub-second. So sub-second query time on this 1 billion record data set. And so what happens is when we set the parameters in Power BI sends a SQL query back to Dremio. Dremio runs that query on the Azure Data Lake Storage and then returns the results. Now, if we went back to Dremio and we went back to the NYC taxi data set that we just had, there's a couple other interesting things that we can do here. One of the things is you can do some last minute transformations, create some calculated fields within Dremio. So if you go, for example, look at trip distance in miles, maybe for the purposes of this experiment or this exercise, we wanted to see this in kilometers instead. So we could very easily click this drop down here, create a calculated field, and apply a calculated field of multiplying trip distance in miles by 1.6, which is the kilometer formula. Change that field name. We're going to keep miles because maybe that would be interesting to for part of our dashboard or part of our visualizations, but not for all of them. We're going to apply this, and Dremio actually writes the SQL for you, but it created a additional field here, which is trip distance in kilometers. We could also create a join in Dremio by joining data sets from additional tables within Azure or from data from other sources like Postgres or SQL Server. And Dremio recommends recommends joins that have been used by people in the past, or you can create a custom join and scroll or search the directory of different data connections and views of the data to find a data set that's right for you. For the purpose of this, we're just going to take the recommended, which is weather and NYC. So what we're going to do is create a new table that's a join of taxi data, but we're going to supplement that with weather data and see how weather impacts taxi usage, passenger behavior, passenger tipping within NYC. So we're going to apply that. And what you see here is, again, if you look at the SQL runner up here, Dremio has written all the SQL for us. We haven't had to write any SQL today, which is always a good day. And if you scroll to the right here, you now have all these additional weather fields to supplement our taxi data. So we're going to save that as a new view. I'm going to save that in my home screen. I'm going to call that NYC plus weather. And I'm going to save that. So that was just a very quick intro into some of the capabilities that Dremio can do and how Dremio really helps Azure users connect to their Azure Data Lake Storage and then really provide a full solution end-to-end from the data lake all the way to the consumption layer with Power BI. Jeremiah, James, back to you.
Hey everyone, so this is Brett Roberts. Thank you so much for attending the webinar today. I'm here to answer any questions. I see that we have a few questions already in the Q&A, so feel free to put your question in the Q&A and we can answer them right now. All right, so I'm just going to start at the beginning. Does the solution target an enterprise data lake, or is it more like a department-based solution? So that's a great question. So Dremio can connect to an enterprise data lake or any data source within ADLS. If you have separate accounts, we can connect to, as you saw in the demo, multiple data lakes, whether that's organizationally dependent or a full organizations. And then the beauty of Dremio is that you can set up projects, you can set up your semantic layer to handle what certain organizations can see and not see. So Brett Roberts in sales might be able to see all of the sales data within my organization, but not anything in marketing, product, or anything, et cetera. So it can do both. Organizations set it up based on kind of how they have structured their data lakes. But as long as Dremio can connect to that data lake storage, we can connect to and then query that data. So a couple of questions I think that kind of align to the same theme around integration. How does Dremio play together with other commonly used services, Purview being one of them? So we have a fairly deep partner ecosystem of ancillary technologies that we connect to within the Lakehouse stack, let's say. In addition to Azure Data Lake as kind of the storage layer, we recently, with our version 22 back in Q2, released native support for column and row access controls. So we are working with other services like Purview and other technologies like Privacera and Plain ID, to just name two, to kind of build that access control layer for column and row and fine-grained access control. Can you aggregate data from other cloud providers, data sources like Google Cloud Storage? Yes, you can. So again, Dremio can connect to a number of different data sources, whether that's ADLS and S3 and Google, and in addition to external sources like databases like Postgres or SQL Server. So you can connect to all those. You can create a catalog of all those connections, and then you can query against them. I just realized that my webcam wasn't on, so now you can see me. Hi, everybody. One of the things you can do is you can actually create tables against data from these different sources or these different destinations. So you can create a view of the data, which you saw in the demo, of data that comes from ADLS with data that comes from SQL Server or S3 or Google as well. Does Dremio have its own data storage tier, or does it create a virtualization query tier on the fly? So we don't store the data or copy the data. The data is in place on the where the source of the data is, like ADLS, and then we query that data directly on that data lake. Now there are a few things like that we do, like reflections, which we create an index or materialized view of the data, and then we store that index on the data lake. But Dremio isn't copying or storing any of the data in its engines. Does Dremio support APIs to write custom connectors for legacy enterprise data sources? So yes, we do have a very rich library of APIs. You can go to Dremio's documentation and see those APIs. We also have a community-based software development kit to create connectors to additional sources. Now, we are absolutely invested in kind of being able to connect to everything. So if you do have a source that you're looking for, I highly encourage you can reach out to me at brett.roberts@dremio.com or to Jeremiah, and we can get you in contact with our product team to talk about what source you're looking for. So how does Dremio discover data to join NYC demo? Okay, yeah. So when we are creating that join where it's the taxi data and the weather data, Dremio is doing that based on within that organization, right? Within that Dremio instance, what other people have done. So if Jeremiah was working with that taxi data and he wanted to connect that to a different data set, the more that will do that, the more the Dremio remembers that that connection or that join has been made, and then it recommends it. So because other people in the organization that I was doing the demo in had created that join in the past, that's why Dremio recommended it. One already. Those. Looking through, see if there's any additional questions. I think there's a question. Okay, talk about partitioning. When we put data into the data lake, how should we partition the data? How does Dremio need a partition? So I think that's a good. It's based on best practice, based on kind of use case specific and the size of the data and the type of data sources. We are optimized for Parquet and for Iceberg table formats. And when it comes to partitioning those files, we kind of list our best practices in Dremio documentation. So I'd highly recommend you take a look at that. I don't have the specifics on how we want it to be partitioned, but I would take a look at our documentation to look at how we actually partition that. And there's a great blog that I can share, Chris. I think that's you asked the question. If you want to send me an email with kind of how we've done partitioning in the past or some of the benchmark tests that we've done in Dremio. I want to trial Dremio on our AWS, but how do I work out AWS cost based on data? So with any cloud, you can use, we have cloud calculators that show you based on what you're doing with Dremio, what that calculation for your compute instances would be. So you can absolutely just try one of those cloud calculators. If you would like to work with someone from Dremio to help with that, again, reach out to me. I think, Mike, you can put my email address in somewhere in here for people to reach out to, and I can help you with your sizing exercises. And I think that there is another question around getting started, which I saw a second ago. So one of the things that how do I get started? Is there a free trial of Dremio? So yes, so there is. So Dremio has a free for life version. You can actually, as you see on the screen here, you can get started with Dremio for free today. You can download that on the Azure Marketplace as a community edition. with that, you get all the benefits of Dremio from a query standpoint. So unlimited number of users, unlimited number of queries, size of queries, data source connections. We don't throttle any of that at all. Really, the difference between the community edition and the enterprise edition is around security and governance, and then some additional features or functionality around reflections as well. But as far as trying it, being able to scale, building out your semantic layer, connecting to Azure storage, and then running this in Power BI or your BI tool of choice, you can absolutely do that with the community edition. Okay, so I think that we answered all of the questions in the chat. Are there any other questions? If I didn't answer your question the way that you were hoping, or if you had a follow-up question, please email me, Brett, BRETT.Roberts, ROBERTS @dremio.com. I'd be more than happy to answer your question or get you into contact with someone who can. So thank you very much and have a great day. Appreciate you all joining us today.